Okay, this is 6.2, integration by substitution. It's often called U substitution or Usub. It says up to this point you've been finding antiderivatives of functions that follow directly from their derivative rules. Today we learn how to undo a function that uses the chain rule to find the derivative. Remember that the chain rule is if you have an inside function, you have to take the derivative of the outside, leave the inside alone, times the derivative of the inside. The chain rule gives us a product of two factors, the outside derivative and the inside derivative. So if a function has this form, then it has an antiderivative. It says use the chain rule to differentiate this. This is my inside function, and then the 12th is my outside function. So I would do 12, leave the inside alone, to the 11th times the derivative of the inside, which would be 12x to the third. This is I took the derivative of the outside multiplied by the derivative of the inside. So what we need to recognize is whether or not each antiderivative is going to undo a chain rule. Well, if you look at the inside here, and then look at 2x, 2x is the derivative of x squared minus 1. So this is actually my u, and this is my du. And I'm going to go a step farther and actually work these out. So what happens, this is what you do. You let u be your inside function, and then you take the derivative of the inside function. Well, the derivative of x squared minus 1 is 2x dx. And then we substitute it. We let x squared minus 1 be u, so it's u cubed, multiplied by 2x dx is du. And then I integrate the u cubed. Well, the integral of u cubed is u to the 4th over 4 plus c. And then all I do is I substitute my x squared minus 1 back in where the u is. So it's x squared minus 1 to the 4th over 4 plus c. Let's look at b. Do you see something that is the derivative of something else? Well, I'm going to still use green for my u and pink for my du. X cubed plus 2 has a derivative. The derivative of x cubed plus 2 is 3x squared dx. Okay? So if I let my u be x cubed plus 2, take the derivative of that, and you get 3x squared dx. And I replace it. Well, it would be the square root of u times du. Because I could rewrite this as the square root of x cubed plus 2 times 3x squared dx. So I've got, what am I in pink? So I've got du, and I've got u. Okay? Then I integrate this. Well, I have to rewrite it just a little bit. That's the same. I add 1, so add 2 over 2, so that's u to the 3 halves, and I divide by 3 halves. Well, if I divide by 3 halves, that's the same as multiplying by 2/3, plus c, and then my last step is to plug in my u, x cubed plus 2 to the 3 halves plus c. And that's my antiderivative. That's my derivative. That's my function. Gosh. C, do you see something that's the derivative? Well, if I take the derivative of what's inside this parentheses, I get 3x squared. That is not 3x squared, so I would not use u substitution to find this antiderivative. Could I distribute it through and then just integrate it term by term? X to the 4th turns into x to the 5th over 5, and then minus 5x squared over 2 plus c. Don't forget to put the plus c. Okay. I think, did I just do this one? No. It is important to note that with substitution, the goal is to substitute all values of the integrand with either u or du. Any extras must be accounted for, or substitution will not work. Okay. So, can we see that our u could be x to the 4th plus 2? because it's the inside function. And that's what you always start with trying. X to the fourth plus 2. Now if we take the derivative of that, we get 4x to the third dx. And that is almost, whoops, not green, pink. It's almost this, but it's not. Okay, so you have to account for the fact that it's not the same. So you make it the same. Well, how can I make it the same? Could I divide it by 4? So I would have 1/4 du equals x to the third dx. Okay, now I'm going to come in and I'm going to replace my u with x to the fourth plus 2. So I'm going to have the square root of u, okay, and then I have x to the third dx is going to be 1/4 du times 1/4 du. Well, that's a constant. I can move it to the front, and I always just put it on the front just because it's easier. And then I integrate it. Well, I would add 2 over 2, so I would have u to the 3/2, but then I have to divide by 3/2, which is the same as multiplying by 2/3, and I bring down my 1/4. Well, if I clean that up a little bit, 1, 2, so that's 1/6 u to the 3/2 plus c, and my last step is to fill it back in. That'll be 1/6 u x to the fourth plus 2 to the 3/2 plus c. Now, you can check your answers on these if you're not sure. How would you check your answer? Well, if you just found you integrated, so to find the original problem, what if I take my derivative? If I take this is my final answer, by the way, but if I take the derivative of this, 3/2 times 1/6 is 3/12. What? No, that's not 12. Try again. 3/12 times x to the 4 plus 2 to the minus 2/2, 1/2, times the inside, derivative of the inside, 4x cubed. If you multiply the 4 and the 3/12, you get nothing, so it's just x to the 4th plus 2, or you get 1 rather, to the 1/2 times x cubed dx, because I took the derivative with respect to x. And that's what I started with, so I know my answer's right. And that's how you can be sure. Example 4, which is right beside it on your paper. I need to rewrite this. Can I write this as sine of 3x squared times cosine of 3x? Do you see that you have an inside function and an outside function? Well, you need to ask yourself the question, is the outside function a form of the derivative of the inside function? Well, always let your u be your inside function. What's the derivative of sine? Well, the derivative of sine is cosine of 3x. But I have an extra term, times 3 dx. Okay? Well, this is close. Alright? It's close. I got cosine of 3x, and I got a dx. And then I've got sine of 3x. What do I need to get rid of that I can't plug in? Well, I need to get rid of my 3. So I've got 1/3 du equals cosine of 3x dx. So I'm going to replace cosine of 3x dx with 1/3 du. And I'm going to go ahead and move my 1/3 to the front. Sine of 3x is u squared du. It's always easier if you can move the 1/3 to the front. If you need to show that extra step, u squared times 1/3 du, and then move the 1/3 to the front, that's fine. It is easier if you go ahead and do it, though. U squared, if you integrate that, you add 1 and divide. You got your 1/3 out front, plus c. So you end up with 1/9 u, but what's u? Sine of 3x cubed plus c. Or you'll see it written as 1/9 sine cubed of 3x plus c. And again, you could take the derivative, and you should get this. You don't have to do this. I'm going to come over here and check it just for good measure. Let me rewrite it. 1/9 sine of 3x. It's easier for me to take my derivatives like this. So if I multiply plus c, if I multiply my 3 to the 1/9, I get a third. times, leave the inside alone, squared, times the derivative of the inside, cosine of 3x, times the derivative of the inside, 3, and then derivative of c is 0. And the 1/3 cancels the 3. That's why you have to have the 1/3 to give you sine squared of 3x times cosine of 3x, which is that right there. So I know I'm right. Here's another one. If I recognize that x is the derivative of x squared, because if you take the derivative of x squared, you actually get 2x, but we can account for the constant. If I let my u be x squared plus 2, okay, my du is 2x dx. Well, right now I have du here, and I have u on the bottom. So I need to get rid of this 2. So I have 1/2 du equals x dx. So I always put my constant in the front. My du is my x dx, so it's on the top, and my x squared plus 2 is my u. You should recognize that as natural log. That's the same thing as 1 over x. Memorize that. That is natural log. So this is 1/2 natural log, and you always have to put absolute value on your natural log, plus c. So it's 1/2 the natural log of x squared plus 2 plus c. And then don't forget a couple of little things. Don't forget your plus c. If you change the variables, the limit will still refer to the original variable. We need to look at how to do these, and let's do the two different methods. It says use substitution to evaluate the integral, but do not change the upper and lower limits. Well, we're going to use u substitution again. So u is going to be our inside function, 1 minus x squared. Du is going to be negative 2x dx. Well, I've got x dx here. I just changed my color. I've been using pink for this the whole time. Oh well. So I need to divide by negative 2. So I have negative 1/2 du equals x dx. So this is going to be negative 1/2 the integral. Now the 0 to 1, I'm just going to hold and just note that it's x is 0 and x is 1. And I'm doing it in terms of u, so that's going to be a little tricky. So it's going to be the square root of u du. Well, let me rewrite that as u, x is 0 to 1 of u to the 1/2, because that's easier to take the integral of. So I'd add 2 halves. So I'd have u to the 3/2, but I'd divide by 3/2, which is multiplying by 2/3. Don't forget your 1/2 in the front. From x is 0 to x is 1. So I can't fill my 1 and my 0 in yet until I put my x back in. So if I clean up this part, I get negative 1/3 u, but u is 1 minus x squared to the 3/2 from 0 to 1. Now my x's match, so now I can fill it in. So it's going to be negative 1/3 times 1 minus 1 squared to the 3/2 minus negative 1/3 times 1 minus 0 squared to the 3/2. Well, this is 0, so this whole piece is 0. And then minus a negative is plus. This little piece is just 1 to the 3/2 is still 1 times negative 1/3 is negative 1/3. But it's plus because I changed that to plus. So I get 0 plus 1/3 is 1/3. Now, to do it the other way, I'll go ahead and show you what the other way was. We'll just pick it up from this piece. Actually, I'm going to pick it up from the negative 1/3 u to the 3/2. Without plugging the u back in, I could have figured out that u is 1 minus x squared. So the x equals 1 and the x equals 0, I could have turned into u's. I could have said at x equals 1, u is 1 minus 1 squared. So u is 0. So at x equals 1, u is 0. And then at x equals 0, u is 1 minus 0 squared, so u is 1. So where this was a 0, here, it was a 0, now it's going to be a 1. And this was a 1, now it's going to be a 0. So you could have done negative 1/3 times 0 to the 3 halves minus negative 1/3 times 1 to the 3 halves, which is still 0 plus 1/3 is 1/3. So you can actually do those either way. Okay, and then method 2, which I just showed you, it's fine. Use substitution to evaluate the integral and change the limits using the substitution rule you created. Well, I'm going to do what I did on the second piece. I see that this is the inside function here, and this is the outside. Well, that's not good. This is the outside function. So if I let my u be 4 plus 3 sine of x, I take the derivative of that. The derivative of 3 sine of x is 3 cosine of x dx. Got to get rid of my 3. So 1/3 du equals cosine of x dx. So what I've got, and I'm going to go ahead and change my at x equals pi, u equals 4 plus 3 sine of pi. Sine of pi is 0, so it's 4. So my top number is 4. And at x equals negative pi, u equals 4 plus 3 sine of negative pi, which is 4 again. And I've got this 1/3, sorry, got confused, du over the square root of u. If I plug it straight in, my green is my cosine x dx here, du on the top, and then my u is 4 plus, so I put it underneath the square root. So I integrate this. This is the same thing as, I really don't even have to do this because I know it's going to be 0, but I'm going to do it anyway. This is u to the negative 1/2 du. So if I integrate that, if I add 2 halves, so that's u to the 1/2 divided by 1/2, also known as 2, and there's a 3 over there, from 4 to 4, that's 0, because anytime the top and bottom numbers are the same, you get 0. And then example 8 is the last one that we're going to do today. Yeah, the rest of that is saved for another day. Is I have tan cubed, and then I have cosine squared. They're not derivatives of each other. But what if I rewrite it as tan cubed times 1 over cosine squared? What is this? You should know. Hopefully you remember, losing my voice, that is secant. And now if I let, excuse me, I'm going to get some water. If you let u be tan, du is secant squared. It says direct substitution. You don't even have to do anything to make it go away. So it's just u cubed du. But you do want to go ahead and change your limits. At pi over 4, if I fill in pi over 4, tan of pi over 4 is the square root of 2 over 2 over square root of 2 over 2, which is 1. And at 0, tan of 0 is 0. So it ends up being just u to the 4th over 4 from 0 to 1. So 1 to the 4th over 4 minus 0 to the 4th over 4, which is 1/4, minus 0, which is 1/4. And that's where we're going to stop. And we're going to park here for a few days because u substitution is a big topic. And it's kind of difficult.